Thank you. Pleasure to be here.
So this is going to be quite a high level discussion and sophisticated. You've really contributed amazing things to this field, and this is going to be very much a granular discussion about the discoveries you've made. I do want to begin by first asking you, how does UV radiation cause melanoma?
So I think we have to recognize a few key features of UV radiation. So ultraviolet radiation is part of the electromagnetic radiation spectrum of what is emitted by sun. It is dangerous by interacting with DNA directly. So the portion of the UV spectrum called the UVB region directly interacts with DNA. The simplest answer to your question is that UV has the capacity to interact chemically or physically with DNA and alter the sequence of nucleotides, resulting in mutations. And this is particularly important in our skin because UV has limited penetration capacity. Melanocytes, the pigment cells, on the other hand, when they get injured by UV radiation and they receive mutations, they don't die. And in fact, often provide melanin pigment that can protect us. But if they do become cancerous, which unfortunately they do all too often, and you take those cancer cells, those melanoma cells, and you sequence the genome of the DNA within those cells, what you discover is one of the highest densities of mutations that are directly chemically attributable to that damage from ultraviolet radiation. So that is the most straightforward mechanism, I think, that is generally considered to be how it is that UV radiation contributes to the formation of melanoma.
Okay, very helpful to understand the basic and the background behind that. So I did read some of your research, which is really fascinating. And I read that red hair, well, as you know, many people know, when they typically say when you're pale and you have, which usually is associated with, sometimes associated with redheads are typically pale. I'll put it that way.